Okay, hello students. My name is Satyajit Pal and today we are in the continuation of Introduction to C Programming. So today also we shall be doing some sample programs on C++. Okay, so let us start with the first program, which is perfect number. Okay, now what is a perfect number? A perfect number means sum of all the factors should be equal to the number itself. Okay, only then it is known as a perfect number. For example, let's say 28. Okay, now 28 is a perfect number. Let us check why. According to the question, according to the statement, the statement, it is given that sum of all the factors should be equal to the number itself. Only then it is considered to be a perfect number. So, okay, let us write a list of all the factors. 1, 2. Now, is 3 a factor? No, it is not divisible. 28 is not divisible with 3, so hence it is not a factor. Then again, what do we have? 4. Then we have 5, no. 6, again no. 7, it is a factor, yes. 8, no. 9, no. 10, no. Then again, what do we have? We have 14, okay, right? So these are the factors. Now you might be wondering that 28 is also a factor, right? 28 is also a factor of 28, right? It is itself a factor of 28, but we don't consider it. Okay, the sum of all the factors means excluding the number. Now what if we add all them? That means if we do 1 plus 2 plus 4, that is 1 plus 2 plus 4, that is 7, plus 7 plus 14. So the resultant is 28. Yes, that's right. The resultant here is 28. Now, is this 28 equal to the original number? This 28, what we are seeing on the screens, is equal to the original number. That means 28 is a perfect number. Right. Now, let us try with 25. Just for assurance, okay? Now, what are the factors of 25? 1, 5, and that's it. Now, is 1 plus 5 equal to the original number? 1 plus 5 is 6. It is not equal to this number. So, hence, it is not a perfect number. So, I hope this thing is clear to you all. Now, to apply this, we have to use again the mod operator, which means if a number, okay, if any number, for example, let us take a number 10. So, if 2 is a factor, it will always give you the remainder 0, or if it is not a factor, if 2 is not a factor of 10, then it is bound to give you the remainder as something other than 0. For example, let's say 1. So if I do, for example, let's say I do 10 mod of 3. Now 10 mod of 3 will give you 1, right? 10 mod of 3 will give you 1. Why? It gives you 1 due to the reason that 3 is not a factor. Okay. So we have to calculate the factors, and hence we need this mod operator, this modulus operator, which you are seeing on your screens right now, this mod operator. This mod operator will help you find out the factors. Okay. Now let us go and check the program. What the program says: int I, num, div, and sum. Okay. I, num, div, and sum. Now let us understand this code. Now let us understand the code. We have the factors I, num, div, and sum. I, you have I, you have num, that means the number, you have div, and you have sum. Now, according to this question, sum has been initialized to 0. So as you can see in the program, sum has been initialized to 0. Now let us enter a positive integer and check whether it is a factor or not. Okay, so now let us enter 28 here. Let the number we have entered be 28 to check whether it is a perfect number or not. Okay, now let us enter 28. Okay, now for int I equal to 1, now I has been initialized to 1. The current value of I is 1, right? The current value of I is 1. Now I is less than this num. Is I less than the num? Is 1 less than 28? 1 is less than 28. For this it is true. This is true, right? 1 is less than 28. So hence this part of the code runs and the control jumps towards this if. Now if num mod of I equal to 0, that means it will do sum equal to sum plus I. Okay, now let me explain it. If num, that is num value is 28, 28 mod of 1, the current value of I is 1, so is 28 mod of 1 equal to 0? Yes, true. 28 mod of 1 is equal to 0. That means what? It is a factor. That means it is a factor. So sum equal to sum plus I. Okay, sum equal to sum plus I. Sorry, there is no need for this div variable here. I guess so. Okay, there is no need. This variable was declared extra. Pardon. There is no need for this variable in this program. This was declared extra. Now, it is given in the question that if num mod of I equal to 0, sum equal to sum plus I. Num mod of I, that means 28 mod of 1, the current value of I is 1, right? The current value of I is 1. So, 28 mod of 1 is equal to 0. That means it is a factor, right? That means 1 is a factor of 28. 1 is a factor of 28. That is why it is giving you a 0 right here as the remainder, right? Now, if it is a factor of 28, sum equal to sum plus I. That means the previous value of sum was 0. Now, I have added 1 to it. Okay, I have added 1 to it. So, the current value of sum gets incremented to sum equal to sum plus I. That means 1. Okay, now again it goes I plus plus. I becomes 2. I becomes 2. The current value of I becomes 2. Now in here again we do 28 mod of 2. It is equal to 0 again, right? It gives you a remainder 0. So hence 2 is also a factor. It means in the next step what you will do, sum equal to sum plus I. That means what you will do, sum equal to sum plus I. That means the previous value was 1, so we will add 2 here, and the concluding result here is 3. The concluding result here is 3. That means 3 is also a factor. Sorry, 2 is also a factor. Now again we shall go to the next statement, that is I plus plus. So you can see in here next, this gets cancelled and the current value of I is 3. Now again it will go and check, is 3 less than this num? Is 3 less than num? True, right? So if now the current value is 3, the current value is 3, right? So 3 is 3 less than 28. Yes, it is true. 3 is less than 28. But if we check 28 mod of 3, this time it is not equal to 0. This time it is not equal to 0, which means that 3 is not a factor. 3 is not a factor of 28, right? So no addition takes place here. Here in this variable, sum variable, no addition takes place this time. Okay, no addition takes place this time. Now again I increment the value of this to 4. Now if I increment the value of this to 4, what happens is that if you check this time 28 mod of 4, 28 mod of 4 will give you again 0. That means this 4, the factor 4 will get added here. So 4 plus 3 plus 4, it becomes 7. Okay, so the updated value of sum is 7. The updated value of sum becomes 7. Okay, now if we go on incrementing and seeing, is 5 a factor? No. Is 6 a factor? No. Is 7 a factor? Yes. If I do 28 mod of 7, what do I get here? I get it again 0. That means 7 is also a factor, so this 7 gets added up here in the sum variable, right? This 7 gets added in the sum variable. Now 7 plus this 7 becomes 14. The updated value of sum becomes 14. Okay, the updated value of sum becomes 14, right? Now again I go on incrementing this. Now again, is 8 a factor? No. Is 9 a factor? No. Is 10 a factor? Will it give 28 mod of 10? Will it give 0? No. Then is 11 a factor? No. Now if we go on like this, we will see that 14 is a factor. 14 is the next factor. So if I do 28 mod of, if I do 28 mod of, if I do 28 mod of 14, it will give 0. So 14 plus 14 gives you 28, right? It gives you 28. Now this 28 is equal to this original number, right? This 28, that means this time this sum became equal to the original number. Okay, this num equal to sum, that means it will go to this if part and it will execute this statement that it is a perfect number. This, my dear friends, is a perfect number. Okay, as because the final value of sum, the final value of this sum is 28, and this 28 is equal to the original number. Okay, now as I said that 28 itself cannot be a factor, so the factors are 1, 2, then you have 4, you have 7, you have 14, the sum of which gives 28. Okay, now let us try and run this code once again. Okay, let us try giving a number 45. It is showing that it is not a perfect number. Okay, now let us try with a perfect number. Let us try with 4096. It is not a perfect number, right? On the other hand, if I try it with 28, yes, right, correct, it is a perfect number. Okay, so this was all about perfect numbers. Okay, now let us move and see the next program, which is a continuation of the previous program. So in the previous program, we had learned about functions. So in here, what we shall do, we shall try to check whether a number is prime or not. Okay, now let us look at the code once again. Void is prime. Now here in here, is prime is the factor. Sorry, is prime is the function where we have passed the parameter n. Okay, is prime is the function. Is prime is the function, and we have passed the parameter n. We have declared a variable n. We will be passing the parameters. Now I and flag is set to 0. Okay, flag is set to 0. Now to check whether a prime number, what is a prime number? What is a prime number? The factors should be 1 and the number itself. Only then it is known as a prime number. Only then it is known as a prime number. Okay, now this is the code. This is the piece of code, or this is the function on which it will work. Okay, now as you can see that it is a user defined function, and if you have seen my previous videos, you can clearly recall what is a user defined function. Okay, right? Now I equal to 2, I shall start from 2 because 1 is a factor of everything. Now let us start with 2. Okay, let us check whether 7 is a prime number or not. Okay, let us check whether 7 is a prime number or not. Okay, now I equal to 2. I becomes I value, the value of I is 2. Okay, now flag here is 0. The flag here is set to 0. Now when this flag becomes 1, it will break this statement and come out of the loop. Okay, now n mod of I equal to 0 means n value is 7. 7 mod of 2, is it equal to 0? Is it equal to 0? That means is it giving a remainder 0? The answer is no. It is not giving you a factor of 0. Okay, now what it shall do, it shall increment it. Okay, it shall increment this. It shall increment this and make I value 3. Okay, now is 3 7 mod of 3 equal to 0? Again the answer 7 mod of 3 is not equal to 0. The 7 mod of 3 is not equal to 0. That means flag still is 0. Okay, the flag value is still 0. Okay, now it will go on incrementing again I plus plus. It becomes I becomes again 4. Now is 7 mod of 4 equal to 0? No, 7 mod of 4 is again not equal to 0. That means it is not also not a factor, right? So like this, if you go on incrementing the value of this to 5, this to 6, and lastly you will update this to 7, right? Now if I check it 7 mod of 7, so yes, it is equal to 0. This time it matches the condition. Now when it matches this condition that n mod of I equal to 0, that means 7 mod of 7 is equal to 0, the flag becomes 1 and it breaks the loop. Okay, the flag value becomes 1 and it gets out of this loop, and it gets out of this loop. Okay. Now, if flag equal to 0, it is a prime number. Okay. Else it is not a prime number. Now let us run this. 17 is a prime number, 20 is not a prime number. Okay. 17 is a prime number, 20 is not a prime number. Okay. I hope this thing is clear, right? I hope this thing is clear. Now, this part you might be having little confusion that, sir, what is this? So, is prime is the function that we made. Is prime here is the function that we made, and this value, 17 value, gets copied to this n. Okay, 17 value gets copied to n. 17 value gets copied to n, and this here, my dear friends, 20 gets to n. Now, what is this 17 and 20? These are known as arguments to this function. Okay, these are known as arguments to this function. Okay, arguments, or you may sometimes call it as values, you may call it as parameters. Okay, so I have passed arguments or values to this function, and through this I am calling this function twice. Okay, I have called this function twice. Now once it will operate with the value 17, it will check with 17, it is not found, that means it is what is that? It is 17 is not a, oh sorry, it is a prime number. Okay, because the factors are only what? The factors are only 1 and 17 itself, right? So if the factors are 1 and 17 itself, it will, what it will do? If the factor, if flag remains 0, it is a prime number, or else it is not a prime number. Now flag value becomes, if the flag value becomes 1, it will break off this loop. Okay, now you can check with 17. That means in 17, if you check, 1 is a factor, right? Now 2, 3, 4, 5, 6, if you go on till 17, 17, if you go on till 17, if you go until 17, you will check that the last factor is 17. Now, we are going to check only till n by 2. That means 17 by 2 is what? 8.5. We are going to check till 9. So, we will check till 9. We have not found any factor. We shall not find any factor. So, the flag still remains 0. Right? If the flag still remains 0, then it will display that it is a prime number. Okay. So, n by 2, you must consider, make it very clear that we will check till n by 2. Okay, we'll not go till 17, we'll just make it 17 by 2 is like 8 and a half. So we'll check it up till 9. So till 9, if we have not found a factor, then the flag still remains 0, and if flag still remains 0, it will display it as a prime number. Okay, I hope this thing is clear to you all. What are parameters and functions, and this program, my dear students, we have done using function. That means we have calculated whether a number is prime or not using a function. And the, what is this? This is the functions declaration. This part is the functions declaration. What you can see on your screens in the red color, this is the functions declaration, and this is the functions definition part. Okay, this is the functions definition part, means what it will do, what this function will do. Okay, what this function will do, it is defined here. Okay, so I hope this thing is clear to you all, and we shall do a next set of programs in the next upcoming classes. Okay, I hope the two programs were clear. The first program, let us revise it quickly. The first program we did was perfect number. Now what is a perfect number? Perfect number is that the sum of all the factors should be equal to the number itself. Only then it is a perfect number. Now when I say that sum of all the factors, it should not include the number itself but the other factors. Okay, for example, in this program, when we did the factors of 28, that is 1, 2, 4, 7, 14. but we didn't take up 28. Okay, so the factors other than the number itself. So if we do the sum, if the sum becomes equal to the number, then it is a perfect number, or else it is not a perfect number. And in the prime function, we are just making the function user defined, and we are just calling the function from main and passing arguments or values to the function from here. This is how you pass values to the function. Now, how many times this function was called? This function was called twice, and hence, when I run this code, the value displays twice. Okay. 17, for 17 it is showing that it is a prime number, 20 it is not showing as a prime number. Okay. So I hope this thing is very clear to you all, and we shall do some more programs in the next upcoming classes as we go on. Thank you, students.